We are given the head of a linked list of integers and also the number of rows and columns for creating a matrix. We need to fill up this matrix with integers from the linked list in a spiral order, starting from the very first cell of the matrix. Now, in case if there are any empty cells in the matrix after using up all the integers in the linked list, then we must fill those empty cells with -1. Before we move on to the solution, it would be better if we watch these previous videos for a better understanding. We know that a linked list is a collection of nodes where each node has a pointer to the next node. Suppose we are given the head of this particular linked list. We will be traversing through the linked list and using those values to fill the matrix until we find a node where the next pointer is none. If the next pointer of a node is none, that means we have reached the end of the linked list. Now let's say the given number of rows and columns are 3 and 3. So we can create a matrix of 9 cells. We can initially fill these cells with -1 so that later on we need not bother about whether the linked list has completely used up the cells in the matrix or not. So even if the linked list did not use all the cells in the matrix, the remaining unused cells will be having the value -1. Now we can traverse the matrix starting from the first cell. We will fill this cell with the value of the current node of the linked list. Now we will move on to the next node of the linked list, and also we will move on to the next cell in the matrix in the right direction. We will continue doing this, and after reaching the third cell in the matrix, we cannot move forward because the next cell is out of the matrix. So we will be taking a right turn from this cell, and therefore we will be moving downwards. Now again from this cell we cannot move forward because the next cell is out of the matrix. So again we will take a right turn from here and move towards left. At this point we have reached the end of the linked list, and therefore we can stop the spiral traversal of the matrix here because as required we have filled the remaining empty cells with -1 already. So this matrix is the final result we have. Now let's take another example. In this case, let's say the linked list has 9 nodes. In this case, we will be filling all the cells of the matrix and we will be stopping the traversal since we reached the end of the linked list. Now let's code the solution. First, we will create a matrix of m rows and n columns, initially filled with -1, and at last we will be returning it. Since we will be starting the traversal of matrix from the first cell, we will be setting I and j to 0 and 0. Also, since we will be moving in the right direction initially, we will set the direction indices to 0 and 1 respectively. Now we will traverse through the linked list till the given head pointer reaches the end of the linked list. Since it is mentioned in the question that the number of nodes in the linked list will not be more than the number of cells in the matrix, we only need to check whether we have reached the end of the linked list. Now during each loop, we will be setting the value of the current node to the current cell of the matrix. After that, we will move on to the next node in the linked list. For visiting the next cell in the matrix, we will add the direction indices to the cell indices and store it in these variables. To check whether the cell indices are inside the matrix and not yet visited, we will write a separate function. We know that the cell will be unvisited if the value in the cell is -1, which we have initially set. Now, if the cell indices are inside the matrix and not yet used, then we can set the next cell indices to I and j respectively. Else we will be taking a right turn and adding the new direction indices to the cell indices I and j respectively. And if even after changing the direction, if the cell indices are not inside the matrix and unvisited, then we must terminate the program. Now let's try running the program. It's working. See you in the next video.